Hey physics people, welcome back to another one-dimensional kinematics problem. This one on deceleration once again. This is example 2. If you missed example 1, be sure to check my channel. Okay, example 1 will be there, and I'm going to do a couple others as well after this. Okay, so in coming to a stop, a car leaves skid marks 91 meters long on the highway. Assuming a deceleration of 6.90 meters per second squared, estimate the speed of the car just before braking. Okay, so just like with any other question, you want to draw a picture. Okay, so let's get started with that first. Okay, so I like to draw something that looks like a timeline, I guess, because it really helps me, write everything down. It's not too cluttered. Okay, so here we go. We want to know the speed of the car before braking. So that's right here. That's our initial speed, V naught. Okay, remember that little zero there, we say naught. Okay, the acceleration from this point to this point right here is 6.90 meters per second squared. But see here it says deceleration. Just be careful with that. Like I mentioned in the previous video, seeing the word deceleration doesn't make the acceleration negative. All it means is that it's opposite the direction of the speed. Okay, in this case, the speed, we assume it to be forward, okay? So the acceleration is going to be negative, but it won't always be the case. Just bear that in mind. Okay, so we've got that. We also know that the skid marks are 91 meters long. That means it took the car 91 meters to stop. Okay, so we're going to say that D equals 91 meters. Okay, that's from there to there. And because it's coming to a stop, therefore the final speed V is 0 meters per second. Okay, so just like a simple problem, just like we've seen before. Now the thing is, we have to figure out what this V naught is, the initial speed. We've got everything else going here for us. And using a formula that we used actually in a previous problem, we can figure out how to solve this quite well. Okay, so for example, you write V squared equals V naught squared plus 2a delta d. Okay, this is one of your kinematics formulas. Except here we're looking for a V naught, so you want to rearrange this formula for V naught. So right now, 2a delta d is being added to that side, so we want to subtract 2a delta d from both sides. Okay, so I don't have much room on my sheet there, but you are subtracting it from both sides, thereby canceling it out on the right. Okay, markers are getting a little bit dry there. And I'm going to bring this to the left, bring this expression to the right just to clean it up a little bit. So V naught squared equals V squared minus 2a delta d. Okay, V naught, generally what you want to do is write the entire expression first. Okay, you don't want to just start plugging in numbers. It's always good practice to write the simplified expression before you actually start plugging in the numbers. Okay, so if you square root both sides, you're going to get V naught equals V squared minus 2a delta d. Okay, so let's go ahead and plug in our numbers. Okay, so V is 0. So 0 squared minus 2. The acceleration is negative 6.90 meters per second squared. And our distance that it has to break through is 91 meters. Okay, so when you simplify this, you're going to get square root of 1,255.8 meters squared per second squared. Okay, when you take the square root of that, you already can see that your numbers are matching up correctly, right? Because you've got a meter squared per second squared. If you take the square root of that, you're going to get meters per second, which is in fact the unit for speed. Okay, so if you simplify that, you're going to get V naught equals 35 meters per second. And just do a double check there. Again, sig figs, right? We've got 2 sig figs here. We've got 3 here. And our answer can only be as specific as the least certain number that we're given in the problem. Therefore, we can only know this up to 2 sig figs, which is what we have. Okay, so there is your final answer and we're done. Okay, so guys, that's it for this video. If you liked it, if you learned from it, please give that like button a click. If you want to see future videos from me or previous ones, be sure to subscribe to my channel. And as always, if you feel that you want to share this with someone, you think someone else can benefit from it, be sure to share it with them through Facebook or on Twitter. Okay guys, that's it for today. Hope you guys enjoy the rest of your day, and I'll see you guys later.